Hi everyone, I'm Alish. Recently I started exploring local AI models, and today I want to share one simple way how you can deploy and use your own Microsoft Pi model on your own machine. So let's get started. So here we are, mastering local AI. Before doing this, before getting into the actual concepts, I just want to shake a little memory on some definitions. And let's start with artificial intelligence. What exactly artificial intelligence is? So the definition you can find, actually, I found in the internet is artificial intelligence is the field of building systems that perform tasks normally requiring human intelligence. Understanding languages, recognizing patterns, making decisions, and solving problems by learning from the data rather than following hard coded rules. So, previously, years back, AI was just about if and else statements where you give some kind of statement where, let's say, if an email is consisting of a random word of scheme or something, get profits or something, where you will list it as a spam, and it goes on, which is again a hard-coded rule that you have to implement in, and which definitely not up to the mark, and you cannot scale it very long. So instead of that, modern AI, it flipped everything. So instead of writing those kind of rules, you show it millions of examples and let it figure out the rules itself. That shift from rule based to learning based is what made the last decade happen. So let's jump on to the next definition, which is language model. So what is actually language model? Is language model is you can consider it as a AI system which is trained to predict the next word, which we call it as token. So it is done in sequence, repeatedly, at scale on trillions of words. So that is how it is formed. The uncomfortable truth here is it's a simple objective, but it is done in sufficient scale, and it is done in a way it produces a system that appears to reason, write, and understand. So the core architecture here is Transformer. It was introduced in 2017 by Google, and you can find it if you type "attention is all you need." This is one of the best papers they ever released, and every model, every language model that you see today, which is ChatGPT 4, Cloud, Gemini, Pi 3, everything is a transformer. The key mechanism here is self-attention. Every token in a sequence can look for another every other token to understand the context. So if you say bank, uh, which means different banks. There are different banks. River Bank is there, Bank account is there. So that will be figured out by the self attention itself. Okay, so this is a little bit about a language model. And if you want to understand what is token means, parameters means, context window, and what is inference, all these definitions will be in the PDF. You can see it there. So how this journey went so far, you can find all the timelines. You can see in 1966 it was started, and RNNs were brought into picture on 1990s. 2017, as I said, transformers is there, and today we are dealing with LLMs and SLMs. What makes is SLMs are the right call? We can mainly focus on privacy because you can run it in your own hardware, so no exposure to the outer world, and cost is pretty simple, zero cost, and offline environment, completely offline environment, and you can train it in a way for focused and specific kind of tasks. So these are sufficient enough to handle those kind of things. Okay, so for now, we are sticking to LLMs, and we'll discuss the large language models in another videos. Like I said, when we try to use LangChain there, and right now, let me switch to the next slide. Can we run SLMs in under 8 GB of RAM? We can definitely.
the model that we are going to use definitely gonna run within 8 GB of RAM, and you are very much okay to try and test it on your end. But LLMs that definitely require higher GPUs, and trying to make it run definitely will cost you something. So be very cautious when you're trying to use that level of models, and always do your research before working with these models. Okay, and before jumping into any demo, let's see what Ollama is. Great. So let's go to Google, see how we can download this. Just type Ollama. Hmm. From this, we can download a simple file, or you can use this installation using PowerShell and all. For now, let me download it normally using AVI for Windows. Yes, this will take definitely a couple of minutes, and let's see. Right, so let's start with the demo. To do that, let's confirm if the Ollama is installed correctly or not. Okay, uh, the connection is not correct. Okay, but the client version is 0.30.8, so Ollama is working. So now let's run it. To do this, the command you can use is Ollama serve. Okay, so with this you can see it is running in the background as a backend engine, and we'll open another PowerShell and see to work with this. So before that, since we already installed Ollama and it is running as a background currently, the next thing what we will be doing is we great. Since it started working and the Ollama engine is working in the background, all we have to do is pull the Phi 3 model. So to do that, all you have to do is give this command Ollama pull Phi 3. So with this, it will start to download somewhere around 2.3 to 4 GB of data. 2.2 it is showing. Okay. All right, it's almost downloaded, and model is available in your local computer. So to work with this, to see if it is giving us a reply or not, let's test it with a simple command and a simple prompt. Um, what I'm gonna type here is, um, but before that, let's see if the model is listed here or not. Okay, so for that, you can give Ollama list. You can see Pi 3 model it is, and ID is this, size is this, modified 30 seconds ago. So we can understand that the model is available in our local PC. And now to test it, what we can do is we can write a command Ollama run Pi 3 with sen- the sentence that I'm gonna giving to this is, what is the big bigotation in a big annotation in one sentence? You can ask that, right? So let's see what is gonna giving what it what it can give us the output, and with this, yeah. So the output it gave us big annotation describes the upper bound of algorithms time and space complexity as a function of input size. So this confirms that we are actually talking with the model and it is replying us back. So with this we can understand that it is giving us the output, and this is the output we can see for the question we asked.